Hi guys, today we are going to be reviewing the Pythagorean theorem for a few problems. We talked about this a couple days ago, but the Pythagorean theorem was when you have two sides of a right triangle, it must be a right triangle. Let me write that down for you though. When you have two sides of a right triangle, you are able to find the length of the hypotenuse by using the formula a squared plus b squared equals c squared. And so there's a couple things that you need to remember as you are using this Pythagorean theorem. First of all, it must be a right triangle. Okay? That doesn't look like a right triangle. Let me make one that looks more accurate. Must be a right triangle, and that your hypotenuse is always going to be on the opposite side of that right angle. And so this a squared and the b squared are going to represent the two sides that make up that right triangle, okay? And the c squared is always going to be representing the hypotenuse. And so the a squared and the b squared, it doesn't matter which one is which, just one of the two sides is going to be the a and one of the two sides is going to be a b. And but this must be the hypotenuse, always must be the c squared. You can't do that out of order, okay? And so if I want to solve this problem to find out what c squared equals, I'm just going to replace the numbers in there. So I'm going to consider this side a and this side b. And so I'm going to plug in the numbers that I have. And so I'm going to have 30 squared plus 40 squared equals c squared. And if I do the math behind it, that I have to remember that 30 squared is 30 times 30 and not 30 times 2. And that equals, when I work that out, it equals 900. And do the same thing with 40 squared, which is not 40 times 2, it's 40 times 40. That's going to equal 1600. And both of those two together is going to equal c squared. So when I add both of these together, I end up with 2500 equals c squared. But in order to, I don't want c squared. I want to find out what the square root of c is, or I want to find what c is. And in order to get this c by itself, I have to take the square root of it. And whatever I do to one side, I do to the other. I know we talked about this in class, so I know that you're pretty familiar with this right now. But if I take the square root of 2500, it's 50. 50 times 50 equals 2500. And the square root of, if I have two c's here, the square root of it, let me explain that a little bit more. C squared equals c times c. And if I'm finding out what number multiplied by each other gives you c squared, that's why the square root of c squared equals just c, because when we're doing square roots of numbers, we're wondering what number times itself gives you the squared number, okay? And so in this case, 50 equals c, and so this side over here is 50 feet, okay? So now we're going to go on to another example problem, and we're going to continue using the Pythagorean theorem, but this time we want to try and find the length of a side. You can pause the video and try this problem on your own if you'd like to, I'll explain it in just a second, okay? We're going to use that Pythagorean theorem again, which is a squared plus b squared equals c squared. And I'm going to look at my two sides. Let's say that this is my a side, this is my b side, and of course this has to be my c side because it's the hypotenuse, which is directly across from the right angle. And so I'm going to plug in my numbers. I do 12 squared plus b squared, I'm not sure what b is, equals c squared, which I know is 15, and so 15 squared. And in this case, I'm just going to solve the problem and simplify where I can. And I know that 12 times 12 is 144, plus my b squared equals 15 squared, which is 225. And now I'm going to go ahead and simplify both sides. I have to subtract 144 from both sides, and I end up with b squared equals 81. And in order to get that b by itself, I have to take the square root of it, just like we did in that previous problem. And so I'm left with b equals the square root of 81. I know that 9 times 9 equals 81, and so the square root of 81 equals 9. And so in this situation, B equals 9 centimeters. Now I'm going to bring in Mr. Collier for this problem because you know me and 3D images, they keep on flipping around in my head, and it's really hard for me to explain it to you without losing the picture and everything. So Mr. Collier's right here, and he's going to walk you through it. So let's start by reading the question. It says a box used for shipping narrow copper tubes measures 6 inches by 6 inches by 20 inches. What is the length of the longest tube that will fit in the box, given that the length of the tube must be a whole number of inches? So, Mr. Collier, can you please help us out with this one?
Sure, I'll give it a try. So, in this case, if we think about it for a bit, we think about that box, we have to figure out what the longest length would be in that box.
Wait, can you hold on a second? Like, I'm getting lost in the picture. So, what is happening in this picture? What are all these dashed lines? And why is there like a dash line going here and here? I'm thinking this is the back of the box, right?
Yes.
But, okay, I'm good with that one. But then, what is that line?
So the line that's labeled S. So the line that's labeled S, it's the diagonal going from, imagine the back corner of the box is where those 3 dotted lines come together.
Uh-huh.
You can't really see it. If you were looking at a real box, those full lines would be what you would actually see. So you kind of have to imagine that what you can't see behind the box is really the rest of the box. And so those are your dotted lines. So you have 3 of them coming together in the back to finish off the shape of the box.
Okay, but this one's
S,
confusing.
Yeah, S is just the diagonal of going from the back corner to the opposite front corner. So it's a diagonal going from the back to the front.
But it's kind of laying across the bottom of the box? Is that what you're saying?
Yep.
Okay, so it's just, like, if I would take the bottom of the box and kind of just draw a line from it with a pen or something like that, or a marker,
right,
then that would be, okay. Now I understand that part. That's what S is in that picture. And the R?
So R is a little bit different, so we have to think dimensionally a little bit different. So we're going from the top corner of the box diagonal to the bottom corner of the opposite side of the box.
Oh, so that would be the tube itself. So if you put it in, then you couldn't lay it flat, and you were okay with it being diagonally inside the box, touching the top corner and the bottom corner.
Right.
That would be what R is. Okay.
So the thing, so for some, maybe it's clear what the best way would be to put the longest tube in, but really the question would be, would S be the right way to do it? That it would lay flat in the box and go from one bottom corner to the other diagonal bottom corner? Or would it be, and that would be S, or would it be better to put it in like R, where it would go from the top back corner to the bottom front corner?
Well, I'm thinking that it should be R because it wanted to know the longest tube, and I'm noticing that R is longer, and I know that when I lay something in a box on the bottom, that it doesn't take as much, and this looks like a hypotenuse to me, and I know that a hypotenuse is longer than other things, and it looks like it's maybe a longer height.
Right. So in this case, you can see a triangle, and so that's really what you're going to use to solve
Which triangle are you seeing?
So I'm seeing a triangle, so the hypotenuse would be R, one of the legs of the triangle would be S, and then if we look at the back corner, we can connect that dotted line from R to S, and there's a right angle in there at the bottom. There you go.
That's a big giant right angle because of my finger drawing it, but I'm sure they get the picture. They're used to me doing this, by the way.
So what we could do is we could, just to help ourselves out, we could end up sort of redrawing that triangle next to the box.
Like this?
Like that, and just kind of labeling some things that we know. So we know R and S. And then for the other side, let's call it H, because we actually know that from the problem that, and we don't want to confuse it with the hypotenuse H, but in this problem we know the height of the box is H,
right there, and
it's
it's
6 inches.
Okay, because this is the same length as this back one over here, right?
Right.
Okay.
So now I know we've talked about
Should
a
I erase
squared.
this?
Sure.
Okay.
I know we've talked about a squared plus b squared equals c squared, but in this case, then we could think like that, but we could also simply say.
Okay.
So what we can write underneath that is we could say in the same way that h squared for this problem plus s squared equals r squared.
Oh, I see. Yeah. Okay. H, S, R. Yeah, because it's the second triangle.
Now, the real Pythagorean theorem is a squared plus b squared equals c squared, but
They
so
had
that's
to label
always
it.
how to remember it. So we could label it like that, and if you're unsure, that's how I would do it. But you could also just say h squared plus s squared equals r squared, and mathematically it's still correct.
But we have a problem because we don't know what S is, and we need S,
Right.
because we also don't know what R is. So I'm taking a look at this now, and I'm realizing that we're going to have to find another triangle
Right, yes.
in order to find out what S is.
Right. So there's another triangle that you can think of, and what we want to be able to solve for is S. So we need to choose a triangle that has a shape where we know the other two parts of the triangle. So I would say that you could draw a triangle where S would be the hypotenuse, and then
This is what I'm seeing.
Yep,
Yeah.
and that is it. So that's another triangle. So
I'm trying to make it straight, and it's just not working. They're so used to this; it's kind of funny.
So, and there's a right angle in that triangle.
Right here, right?
You got it, yep.
Even though it kind of looks crooked, it is a right triangle because it's the bottom part of the box.
So let's rewrite that triangle.
Okay.
On the side as well.
So this would be this, and this was S.
So in this case, in this triangle, yeah, that's
we don't know what S is, and we know this one is the L, right, which equals 20, and we know that this is the same thing as this width, which
so W
and that was a 6. But because we do a squared plus b squared equals c squared, then we know that 6 squared plus 20, that's a 6, not a b, just so you know, plus 20 squared equals s squared, right?
Yep.
Okay, so that would be 36 plus 400 equals s squared. Mm-hmm. Did I do my math right?
Yep.
So 436 equals s squared, and I take the square root of both.
Yeah, and this is not such a nice number as your previous problem,
great.
But s is going to equal 20 do you want one decimal or two?
1 is fine.
Okay, 0.9. I'm going to round up, so 0.9.
Okay,
inches.
And it was inches, right?
Yep.
Okay, so good. So now we found out what S is, so now we took care of this guy. So now we have our two sides, right?
So, and we know
so,
what H is, so we can do
so
that.
now we're switching back up to this triangle to get this guy because we wanted to know what R is, right? Okay, and so we've got 6 squared plus 20.9 squared. Well, that's funny because we just took the square root of it.
Right, so we actually...
So we actually didn't need to do that.
Which is fair, but at least it's good practice.
Okay,
so,
equals R squared. So instead of rounding this number, I'm just going to keep that 436 in there.
Yep.
So I'm going to do 36, right?
Yep.
Plus, I'm going to go back to this number because it's more exact than our rounding. 436 equals R squared. 36 plus 436 is 472 equals R squared. And so we're going to have to take the square root of that. You got a calculator on it? So R equals 21.72 inches. I'll go 2 decimal points on that one. Okay,
but now you have to go back. So if it wasn't 100% clear, I know some people are visual and some aren't, and you weren't sure, is S or R the right way to put the longest tube in, we would just look at our answers for S and R.
Oh, good point.
And see that if we put it in like R, we can put a little bit longer tube in. But we need to also go back. The problem asks specifically for the longest tube in whole number of inches.
Oh, good point, Mr. Collier.
So
R, I'm going to round it to...
Well, not round it.
Or estimate it.
Has to be a whole...
Whole number. Oh, it's going to have to be 21. I'm going to actually have to round down because we can't round this up, even though this number should be rounded up according to rounding rules. Yeah, it'd be sticking out of the box. And so in this case, even though we would be, like, we'd want to follow typical rounding rules, we can't in this situation. Okay, well.
So, and then the other one to the whole inch would also be 21. So,
yeah.
The reality is you could put.
But you could theoretically get.
If you weren't doing it by whole inches, R would be the correct way to get the longest possible tube in there. But since we're worried about whole inches, actually the problem works out where it doesn't matter, if you put it in the S direction or the R direction.
Okay. Well, thank you, Mr. Collier, for helping us out with this problem. There are some other problems that you can work on in your book under this section titled Pythagorean Theorem. Any other advice?
No, just keep remembering a squared plus b squared equals c squared, and you should be fine.
All right, thanks so much.